Alright, 4.2 talks about the definite integral. Let's recap where we were. Looking at a function y equal f of x. If I would like to find the area between a and b, I will cut this into n subintervals. So I'll call this x sub 0, I'll call this x sub 1, I'll call this x sub 2, x sub 3. Now in there somewhere, there is the ith. That's x sub I minus 1, that is x sub I, and it continues on. And this last is x sub n minus 1, and we call b x sub n. So we start with x sub 0 and terminate on x sub n, where we have n subintervals in there. And we say area is going to equal roughly we're going to use r sub n. We're going to always use r sub n. We could use L, we could use M. Well, that's going to be what? That's going to be f of x sub 1 on the first interval times, so this height, because the right end, times this width. But that width right there is delta x, which is b minus a over n. Plus, on the second interval, we're going to take the right end to be the height, f of x sub 2 delta x. And on the last interval, we're going to take f of x sub n times delta x. So we're going to say area is roughly, if I factor delta x out, f of x sub 1 plus f of x sub 2 plus f of x sub 3, and the list goes on, plus f of x sub n delta x. And if I write that as summation, area is roughly that. And of course, if I fit in an infinite amount of those rectangles as n approaches infinity, n equal 10, 100, a million, a trillion, then that area will become exact, where x sub I is I plus a times, is a plus I times delta x. I'm going to give you an example on that to make sure that you see that. Right, and delta x is simply b minus a over n. So if I was looking at an interval, this is just an example for you to see this part. If I was looking at an interval, let's say I'm running from 3 to 7, and I want n equal 4. So delta x is automatically 7 minus 3 over 4, that is 1. So when I say x sub I is a is the starting point, plus I times delta x. So when you look at the first subinterval, when I equal 1, x sub 1 is x sub 4. Do you agree? Isn't that the first height? When you look at the first interval, don't you take this to be the first height? If you look for x sub 2, x sub 2 in the second subinterval, in this subinterval, you want the right endpoint, so put a 2 in there. That would be 3 plus 2 times 1, which is 5. And there it is. And that's how it works. So to sum up what we talked about, definition of a definite integral, this is also known as the Riemann sum. If f is a function defined between x equal a and b, we already did that, we divide that interval into n subintervals of equal length. We did that already. We let this be a and this be b, be the endpoints of these subintervals. Here they are. And let, this is the new deal, x sub 1 star, x sub 2 star, x sub 3 star, x sub n star be any sample point in those subintervals. So the difference is, we are used to choosing left or right. Here, the exception, if I look at x sub 0, x sub 1, x sub 2, x sub 3, all the way to x sub n. Here, x sub 1 star could be right there. X sub 2 star could be a right endpoint. It could be anywhere. In the third interval, you could choose X sub 3 star to be anywhere. The deal is, if you take in the limit as n approaches infinity of those are going to become infinitely close, that no matter where you choose this, it's going to find the correct height, provided you have n large enough. If that's the case, then we say this summation right here equal the integral from x equal a to x equal b of f of x dx. Provided this limit exists, right? And if it does exist, we say f is integral over a to b. The condition is that f must be continuous on that integral, right? We want to be defined on that integral. So recap, the integral from a to b, this is the lower limit. This is the upper limit of this integral. This is the integral symbol. It's sum. This is what you are integrating, f of x, and that's the width. Is the area above the x-axis under y equal f of x from a to b if f of x happen to be positive. So, if you look at y equal f of x and it happened to be positive, if you integrate from a to b, that will find you that area that we've been looking for all along. Here's an example. If I'm looking at this, now keep in mind, an integral has many applications. One of them is area. If I want the area, and I notice that it's going to run from the x-axis to f of x, do you notice that f of x is negative? So this is going to give me, if I go for an integral from a to b of f of x dx, that's going to give me a negative answer. If I really want the area, I make that a negative. So I have to visually look at f of x and make sure that it's always positive. An integral tells you the overall displacement of where you are compared to what you started with. You want to make it area, make sure that you view it and input a positive every time, or put an absolute value on it, which is the same thing. So, your odometer on the car, whether you drive forward or drive backward, it adds to the odometer reading, right? The old cars, when you move forward, the odometer used to go forward. When you go backwards, it used to roll back. They fixed that. Now, whether you move forward or backwards, that would read positive. That is, if you are at a point, if you drive 4 miles forward and you drive 3 miles backwards, you really drove 7 miles. If you integrate this function, right, the drive, whatever that is, the answer will be 1. An integral will tell you, compared to where you started, now you are 1 unit. So the overall, the displacement altogether, compared to where you started, an integral finds where are you now. You want to figure out the 7 miles, put an absolute value on this. That will ensure that it's always positive, and that will give you the 7 miles. And we'll point that out as we do more examples. Let's look at the first example here. Express the limit as a definite integral. Well, it is x sub I star, so this is going to be limit as n approaches infinity, the integral from a to b. What's a? A is 0 to pi over 2. Delta x is right there. What do you replace? Remember, this should be f of x sub I star. What do you replace f of x sub I star in to get x sub I, the sine of x sub I plus 1? There. Done. And here, again, it's the limit as n approaches infinity. This would be the integral from 1 to 5 of 5 over, again, this is going to represent f of x sub I star. So what did you replace x sub I star to get 5 over x sub I star plus 1? Fairly simple. Now, rules for integration. evaluate the integral by using the definition. The definition says this summation equal that integral. So the definition says the integral equal the summation. Only in this section, when we use it, we're going to say that's the limit as n approaches infinity of the series I equal 1 to n f of x sub I star delta x, where x sub I star is a plus I delta x. It is 1 plus I times delta x, and delta x is b minus a over n, 3 over n. So we're going to say, and f of x is 5x. So we're going to say this is the limit as n approaches infinity of the series I equal 1 to n, f of 1 plus 3I over n times delta x. Delta x is 3 over n. And the problem becomes a limit issue. That is the limit as n approaches infinity of the series I equal 1 to n, and f of x sub I, f of x equal 5x, so this is 5 times 1 plus 3I over n. Need a bit more space. These are provided on your test. So this is going to be the limit as n approaches infinity. I'm looking at the series I equal 1 to n. Do you notice that this series depends on I? That's a constant. That's a constant. I could drag that up front. That's properties of summation. So I could drag 15 over n out. And I'll be looking at 1 plus 3I over n. This is the limit as n approaches infinity of 15 over n times the series I equal 1 to n of 1 plus 3 over n times the series I equal 1 to n of I. And if I follow this, that would be the limit as n approaches infinity of 15 over n. And here, it's simply n times 1. And this summation is right there. That is n into n plus 1 over 2. And now it's nothing more than a limit problem. So that's the limit as n approaches infinity of 15 over n times n plus, these n's cancel out. That's 3/2 n plus 3/2. So I would say that is the limit as n approaches infinity. If I distribute that in, that is 15 plus 45 over 2 plus 45 over 2. And as n approaches infinity, this will approach 0, and I'm left with 15 plus 45 over 2, or O over 2, that's 30, 75 over 2. And that would be my area under that curve if I was to graph it between x equal 1 and x equal 4. And here's another example. Same deal. Here I need to figure out what each of those are. Well, I know what f of x is. F of x is x squared. Delta x is b minus a over n. That is 4 over n. And x sub I is a plus I times delta x. So that is 2, the starting point, plus I times delta x. There it is. I'm going to take those, put them on the side. And I'm going to say this is going to be the limit as n approaches infinity of the series I equal 1 to n of f of x sub I, that's 2 plus 4I over n squared times delta x, 4 over n. Now I notice this is I changing, so the 4 over n I could factor out. And I'll be taking the series I equal 1 to n of plus 2ab, so 8 16i over n plus 16i squared over n squared. That is 4 over n. I forgot the limit. That's a big issue. Limit as n approaches infinity. And this will be the series I equal 1 to n of 4 plus 16 over n the series I equal 1 to n of I plus 16 over n squared the series I equal 1 to n of I squared. So that would be the limit as n approaches infinity of 4 over n. And let's talk about, this is 4 times n. This is 16 over n times I. I, we have it as n into n plus 1 over 2 plus 16 over n squared times the series of I squared. And the series of I squared is n plus 1, 2n plus 1. n plus 1, 2n plus 1 all over 6. And here we are. The limit as n approaches infinity. I'll take the 4 over n, leave it out for a minute. I'll simplify a bit. This divides that 8 times. Those cancel out. That's 8n plus 8. And here you notice divided by 2, that's a 3. Divided by 2, that's an 8. And one of those n's cancel with one of those. So I'm left with, I could FOIL that, I could leave it as is. I'm going to FOIL it. 2n squared plus 3n plus 1. And that would be the limit as n approaches infinity. Let me see if I can move that a bit up there. And that would be the limit as n approaches infinity. And now let me see what I'm doing. If I am to distribute that in, that will be 16 plus 32, the n's cancel out, plus 32 over n. There are other ways of doing this, of course. Now, if I multiply 4 over n by 8, that's 32 over 3, and that will be n squared. Distributed n, if I distribute the n squared in, that will be 2 plus 3 over n plus 1 over n squared. That's another way of doing the problem. The limit as n approaches infinity, any quantity over n will zero out, and here it is. That will be 16 plus 32 over 3 times 2. That will be 48 plus 64 over 3, all over 3. That is 12, 24, 144 plus 64. And this exact area will be 208 divided by 3.